Hello, 7th grade. We are going to talk about exponents and our rules of exponents when we are going to multiply exponents together, divide exponents, negative exponents, and zero exponents. So there should be some review, but we're going to kind of go more in depth. So we have our product of powers property. This is when we multiply powers with the same base, you add the exponent. So again, remember, the base in this case is 4, and our power is 3, and the base is 4, and our power is 2. So 4 cubed times 4 squared. So what we would do is we keep our same base 4, and then we add 3 plus 2, and we get 4 to the 5th. So to show how this works, if we have 4 cubed, that's 4 times 4 times 4, and 4 squared is 4 times 4. So if we multiply them all together, we have 5, so 4 raised to the 5th power. So an example with variables is you have b to the 10th plus b to the 8th equals b to the 10 plus 8, which in turn equals b to the 18th power. You can also do this using integers and variables, so numbers and letters. So if I have 5m squared times 6m to the 4th power, I can actually rearrange these because we're multiplying everything together. Because remember, when you have 5, like a number, and m squared and a variable next to each other, it's multiplication. So ultimately, I can rearrange this because of my community property of multiplication, and I get 5 times 6 times m squared times m to the 4th. Then because of my product of powers property, I'm able to combine my powers with the base of m. So I have 5 times 6 times m raised to the 2 plus 4. I might add my exponents, 5 times 6 times m to the 6th, and then I multiply 5 times 6, and I get 30m to the 6th power. And now we can also talk about quotients of powers. So when we divide with exponents. So divide powers with the same base, subtract the exponents of the denominator from the exponent of the numerator. For example, 6 to the 8th divided by 6 to the 5th power equals 6 raised to the 8 minus 5, which equals 6 cubed. If I show this out, I have 6 8 times and 6 5 times, and you can see that these cancel out to 1. So it's kind of like 1 times 1 times 1 times 1 times 1 times 6 times 6 times 6, and I'm left with 6 cubed. So it's the same answer. So a couple examples here. 5 to the 8th divided by 5 cubed equals 5 to the 8 minus 3 power, which equals 5 to the 5th. We can also do this with integers and variables. So if I have 7c to the 9th divided by 21c cubed, I say, okay, well, my c's now, we're going to go with our quotient power property, and I have 7 to the c, 9 minus 3, so again, numerator minus denominator, divided by 21. So I have 7c to the 6th divided by 21 after I subtract my exponents, and then I reduce my fraction. So I reduce the fraction with a GCF of 7, so I divide by my numerator and denominator by 7, and I'm left with c raised to the 6th power over 3. Now I could have a 1 right here, but it's not necessary. But remember, you have your c to the 6th power is on your numerator. So here's an example using both the properties, the product of powers and the quotient of powers. So 5x to the 4th times x to the 6th divided by 10x to the 5th. So first I want to combine my numerator x's. So I have 5 to the x raised to the 4 plus 6 power divided by 10x to the 5th. Add them up, and I have 5x to the 10th divided by 10x to the 5th. Then I take my quotient of powers property because I want to get my denominator x's and my numerator x's and combine them, and I have 5x to the 10 minus 5 divided by 10. That subtraction of the exponents is 5x to the 5th divided by 10, and then I reduce my fraction of my GCF of 5, so divide numerator and denominator by 5, and I get x to the 5th divided by 2. Here's a little more complex version, but the same properties are used. 4ab times 5a squared b cubed. So again, everything is all multiplied together here because everything is next to each other. So I can rearrange it with the commutative property. 4 times 5 times a squared times b cubed. So now my product of powers, so I have 4 times 5 times a to the 1 plus 2, because remember, a by itself is kind of like a to the first power, times b to the 1 plus 3. Add my exponents, 4 times 5 times a cubed times b to the 4th, and then multiply my numbers, and I get 20a cubed b to the 4th. And when you write it, you want to keep them all together and keep your variables in alphabetical order. Here's another one with division. So 24 w to the 4th z to the 9th divided by 15 w squared z cubed. So my quotient power enables me to combine my w's and my z's. So I have 24w to the 4 minus 2 times z raised to the 9 minus 3 power, all divided by 15. So do not drop your denominators. Always bring over what you're not using. And then I subtract my exponents, so now I'm left with 24w squared z to the 6th power divided by 15. Reduce using a GCF of 3 in this case, and I get 8w squared z to the 6th divided by 5. So those are our power products of multiplying and dividing. Now let's talk about negative and zero exponents. We're going to start with zero exponents because it's a little easier to get to. But any non-zero number raised to the 0 power is always 1. That is our rule, and we'll go and show you and kind of prove it here in a minute. But it's like 36 raised to the 0 power equals 1. 786 raised to the 0 power is 1. 1 million raised to 0 power is 1. So everything. 1/3 raised to 0 power is 1. Okay, so the whole thing. And then our other one, it's a little harder to write down, but I think you'll understand the concept after a couple examples. Any non-zero number, like a, raised to a negative exponent, like negative n, is, so a raised to the negative n is equals 1 over a to the n. So it makes it into a fraction. So for example, 5 raised to the negative 2 is 1 over 5 squared. 3 y raised to the negative 2. So this can get tricky because your exponent in this case is only connected with the y, not to the 3. So your 3 stays in your numerator, and then it's like 1 over y squared. So you get 3 over y squared. So let's talk about how this is true. So if we start using something like 2. So 2 cubed we know equals 8. 2 squared, 4. 2 to the first, 2. So 2 to the 0 is 1 because of our rule, our 0 rule. Now, 2 raised to the negative 1 is 1 over 2. 2 raised to the negative 2 is 1 over 2 squared, which is 4. So 1/4. 2 raised to the negative 3 power is 1 over 2 to the 3rd power, which is 1/8. So you can see as our exponents decrease by 1, 3, 2, 1, 0, negative 1, negative 2, negative 3, the values of the powers in this case are halved. So you go 8, if you say divide by 2 is 4, divide by 2 is 2, divide by 2 is 1. 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. So everything is halved. But basically what it is based on your base. It's based on your base. It's related to your base. So it's 2 in this case. So that's why it's halves. Let's use another example using the power of 10 because those are usually easier too. 10 cubed equals 1,000. 10 squared equals 100. 10 to the first equals 10. 10 to the 0 equals 1. So on and so forth. And you can see here we divide, it decreases by a division of 10. So 1,000 divided by 10 is 100. 100 divided by 10, 10. 10 divided by 10, 1. 1/10, 1/100th. So these are examples of how you write it. You write the expression using only positive exponents. So 7, negative 2. So again, this negative is attached to the 7, so it's 1 over 7 squared. A to the negative 5, b to the 0. Well, my negative 5 is attached to my a, so that's 1 over 5, a to the 5th, and then b to the 0 is 1, so I'm left with 1 over a to the 5th. This one's a little trickier. 4m to the negative 4, n cubed. So my negative 4 is attached to my m. So that's the only one that we're going to put over 1. So my 4 stays in my numerator, and my n cubed stays in my numerator, and then my m to the 4th, because it's like 1 over m to the 4th, is now on the denominator because you're multiplying them all together. And then going the other way, write expressions without using a fraction bar. So if we have 1 over 25, well, that equals 1 over 5 squared. and then I can redo it. I know it's on the denominator, so it has to be negative. So that equals 5 raised to the negative 2. Here, x to the 6 is my numerator, so it stays positive. Y cubed is on my denominator, so I know that this has to be a negative exponent because it's less than 1. So I have x to the 6, y to the negative 3. And then one more complicated problem, we're done. So we have 10a to the 4th divided by a to the negative 4th. So I keep this in my numerator, 10a to the 4th, and then I'm going to multiply it by a to the 4th because it's a negative 4. So I want to bring it up because it's also the opposite. We'll talk about dividing fractions, but you bring it up and I get 10a to the 4 plus 4th, which is 10a to the 8th. And we'll do these problems together more in class, but just so you're exposed to it. So take good notes, and we will work more of these in class.